Hello guys, this is the video for 5.1 part 1. I'm only covering medians and centroids on this. We'll do 5.4 part 2 next block. It was just too much to cover in one block. So again, this is only going to be the medians and centroids. So for this section, we need to talk about medians. So medians, it's the segment from a vertex to the midpoint on the opposite side. So looking at my picture, it starts at a vertex and it goes to the midpoint on the opposite side. So if I call BD a median, that means that D is a midpoint, which means AD and DC are the same. Before I go any further, I want to make sure you see the difference between all the different terms we've used so far. So again, today we're talking about medians. Starts at a vertex, ends at a midpoint. Quick recap of what you already know. Perpendicular bisectors. This is just a quick sketch. This was 5.2. So perpendicular bisector, perpendicular divides it into two equal segments. Perpendicular divides it into equal segments. Perpendicular divides it. This meeting point is the circumcenter and it is equidistant to each vertex. If you remember that from, I believe that was Monday. 5.3 said angle bisectors. So this is an angle bisector, this is an angle bisector, and this is an angle bisector. That angle bisector, the very center, is called the in-center, and the in-center is equidistant to each side. So these pink lines are all equidistant. Today, we're going to be looking at medians. Medians start at a vertex, ends at a midpoint. So this is a midpoint. Starts at a vertex, ends at a midpoint. Starts at a vertex, ends at a midpoint. I'm sorry, my lines are not straight because I have my hand on my phone and it's hard to hold my paper. Okay, so look at the difference between these. Perpendicular bisectors, they meet at the circumcenter. Angle bisectors meet, and it's called the in-center. Where the medians meet is called the centroid. So this is a good review of what you know so far. Back to our notes. So again, the median starts at a vertex, ends at a midpoint. I want you to see the difference between a median and a mid-segment because they're easily confused. So again, a median starts at a vertex, ends at a midpoint. So it joins a vertex and a midpoint. Whereas a mid-segment joins two sides. It never touches a vertex. Look at the difference between what a median is and what a mid-segment is. Mid-segment joins the midpoints of two sides. Median starts at a vertex and ends at the midpoint of the third side. I do have a construction of a centroid, and I do have this posted on Schoology. I would like you guys to just look at it. Again, when I'm back in the classroom, we will be doing these constructions together. I just don't want you doing them without me there because that is a little bit tricky. So the centroid is the meeting point of all the medians. So in this case, this is our centroid. So taking this a step further, you can look at this picture and you can see that BF is a median. I know that because it starts at a vertex and it ends at a midpoint. See, these markings here tell me that F is my midpoint. So because F is a midpoint and it starts at a vertex, BF is a median. Same thing with AE. AE is a median. It starts at a vertex. E is a midpoint. You can see with these two markings. CD is a median. Starts at a vertex, ends at a midpoint. I know that because of those markings. So taking this a step further, once I know that G is my centroid, that means that we know more information about these lines. This right here is what I'm talking about now. Medians of a triangle are concurrent at a point that is 2/3 the distance from each vertex to the midpoint on each side. That's a lot to think about. Let me make sure that this makes sense. So first of all, I just told you that BF is a median. The rule says BG from the vertex to the centroid is 2/3 of the entire length. From the centroid to the midpoint, this segment is 1/3 of the entire length. And being that you know fractions, 2/3 and 1/3 is the entire length. So from the centroid to the midpoint is 1/3 of the entire length. From the vertex to the centroid is 2/3. So you can also look at all the other ones. So let's look at median AE. A to G would be my 2/3 part. G to E would be my 1/3. Vertex to centroid is 2/3. Centroid to midpoint is 1/3. And just to make sure it makes sense, let's look at DC. Vertex to centroid is the 2/3 part. D to G, the centroid to the midpoint, is the 1/3 part. Make sure you see the difference between the two because you'll need that to find the lengths of different sides. Let's look at an example. So in the directions, it says S is the centroid of triangle RTW. As soon as they tell you that that's the centroid, we know all of this stuff that we said above is true. So anytime they give you information, you should always mark up your diagram. I've always told you guys that. So we say RS is 4, so that's already marked here. VW is 6, that's marked here. And TV is 9. Be careful how you mark this, that it doesn't cause you problems of understanding. That's why I like to use colors. This entire length is 9. So we're asked to find different parts of this triangle. So the first one, it asks you to find RV and VW. So if we look at what I have here, excuse me, RV is going to be the same as VW. And we know VW is 6, so RV has to be 6. So again, if I'm finding RV, because S is my centroid, I know that V is a midpoint. If it's a midpoint, then VW and RV have to be the same. So if VW is 6, RV will also be 6. Number 2 asks you to find SU. So SU is this segment right here. So SU is my 1/3 piece. RS is my 2/3 piece. It goes from the vertex to the centroid. So what I did was set it up as kind of a formula first. So SR is 2/3 of RU. SR is 2/3 of RU, 2/3 of the entire length. And remember, of means multiply. So then I know that SR is 4, and now we have one unknown. So in order to get this RU by itself, we multiply both sides by 3/2. 4 times 3 is 12, divide by 2, and that gives me 6. So RU is 6. So looking back up here, if RU, this entire length is 6, and this length is 4, that means that SU has to be 2. Moving on, we're asked to find RU, which I actually just found, so I'm not going to go over that one again. RW. RW is 12 because we know that V is a midpoint, and if VW is 6, RV also has to be 6, which means the entire length is 12. Look at TS. So TS is this segment right here. TS is my 2/3 segment because it starts at a vertex and it ends at the centroid. So look how I set this up. I said TS is 2/3 of TV. TS is 2/3 of TV. I plugged in TV as 9 because that's the information that I know. And then I simply multiplied. 9 times 2 is 18, divided by 3 gives me 6. This step right here is really important. Do not try to set up your equation without it because it's really easy to make a mistake. If you notice the difference between how this one is set up and this one, you know, I put the 4 on the left-hand side and I had to actually multiply by the reciprocal. Over here, I just had to multiply. So make sure you're putting things in the correct spot so you don't make a mistake. And the last example asked you to find SV. Well, my last example helped me with this. So if TV is 9 and TS is 6, let me kind of do a quick sketch here. T, S, and V. We know that the entire length is 9. We just figured out from our last example that this is 6. We're asked for this segment. So if the entire thing is 9 and this part is 6, this part has to be 3, and that's where that answer came from. Okay, here is your homework. You will need graph paper for a few of these problems, and I want to talk about them. So here's your homework. If you want to pause the video and jot down your homework. I do want to point out that there's a few problems on here. For example, number 9, you're going to plot the 3 points. You're going to find the midpoint of each side. So for example, when I calculate the midpoint of AB, I can plot that point, and then I can very simply draw that median. If I know where the vertex is and I know where the midpoint is, I can draw a median pretty easily because we know how to find midpoint. Then once I draw all 3 of those medians, I can very easily find that centroid point. So number 9, number 10, you'll need graph paper, and number 41, you'll need graph paper. So for those 3 problems, you should know that I have graph paper in the back of the room. There should be little sheets of paper like we've had before. You'll need 3 of them for your homework, or you can use your own graph paper. Email me with any questions. Take your time with these. It's really easy to make a mistake, and be careful with them.